Hi guys, Mr. Gillen here with the final part of the Pythagoras topic. And before we look at examples or anything, I want to look at a few important points about a circle that we're going to have to know. First thing I want to look at is a chord of a circle. So a chord is a straight line segment whose endpoints both lie on the circumference of a circle. And you can see on the diagram, we have got the line AB going from there to there, and we would classify that as a chord. A perpendicular bisector is a line which cuts another line in half and does so at right angles to the first line. So again, if you look at the diagram, we've got this line OC, and it is a perpendicular bisector for the line AB, which means that it cuts it in half. So we can say that AC is equal to BC. Those lines are the same length because they've been cut in half. This is important knowledge for some problems in Pythagoras. Tends to be exam style questions. This comes up quite often during the course of an exam, so it's important that we look into it in more depth. So let's look at an example. We've got a circular road tunnel with a radius of 10 metres is cut through a hill. The road has a width of 16 metres, and we're looking to find the height of the tunnel. And we can see in the diagram here, we've got the tunnel, we've got the road at the bottom with our 16 metres, and we've got the 10 metre radius. So there's a few things that I can mark in just now that will probably make this a bit easier for me. I want to find the height of the tunnel, so that's going to go from the road all the way to the top. So I know instantly that from the centre of the circle to the top of the circle is 10 metres because it's also a radius. In order for me to find the height though, I need to find the distance between the centre of the circle and the road, which we'll call x metres. Now instantly when I've drawn that line, I'm able to recognise that the road itself, even though we can't see it, is cutting off a part of the circle. So the road itself is a chord. And the line that we've marked as x has now become a perpendicular bisector. And what I've got as a result of that is I've got a right angled triangle. Now, as you probably know from previous examples with Pythagoras, if we've got a diagram that we've managed to find a triangle, I quite like to redraw the triangle, just so it's easier for me to work with. And as you can probably notice, I've marked in the bottom with 8 centimetres, or 8 metres it should be. Take that out. 8 metres because of this perpendicular bisector. So I've now got a right angled triangle. I can now use Pythagoras in order to find that missing side. As always, the longest side is going to be marked with C. I'm trying to find a shorter side, so what I'm really going to be doing is rearranging my formula. So I've got a squared equals c squared, subtract b squared. And then from there, I'm going to substitute in, as I would normally do. And solve to find what x is. So I've got x squared is equal to 36. I want x on its own. The opposite of squaring something is the square root. So in this case, x is equal to 6 metres. Now, one of the stumbling points we always find each year is, at that point, people tend to stop. We haven't answered the question yet. The height of the tunnel is going to be this 10-metre radius, if we go back to the diagram, added on to the x dimension, but we've just worked out. So the last part I need to write in is x, or the height, sorry, is 16 metres. So the key point in here is make sure that you look for the right angled triangle. Recognise any perpendicular bisectors, and then make sure that you always answer what the question is looking for. Quite a quick video, but as always, if you've got any questions, please don't hesitate to get in touch with me. This is Mr. Gillen signing off. Speak to you all soon.